Now let us have a look at one question related to theorems. It's a very popular question. Let's see. What must be the value of R such that maximum power gets transferred from source to load? Okay. Now let me draw that circuit here. Let us assume that this is 6 ohm, this is 12 ohm, and this is R. So this portion is a source portion, and this is the load portion, and let us say this is Thevenin's voltage VTH. Okay. Now what is the question? The question is, what must be the value of capital R such that maximum power gets transferred from source to load? As you all know, what is maximum power transfer theorem? Maximum power transfer theorem states that maximum power is going to get transferred from source to load when load resistance is equal to source resistance. Okay. Then immediately you might think, what is the load resistance? 6 ohm. Then what must be the source resistance? 6 ohm. Out of which how much is already here? 12. 12 parallel to how much will be equal to 6? 12. Then immediately you might say the answer is 12 ohms, which is absolutely wrong. Why? Why is it wrong? Why it is not 12? Let me give you one practical way of understanding this. Imagine one fine day, God appeared in front of you and gave you one wonderful chance, one wonderful opportunity. Guess what is that opportunity? You might think to be little big. He gave you one technical opportunity. You know what is that? He gave you one wonderful opportunity to vary source resistance. You must be laughing. Varying source resistance is not a joke. In general, who will be variable? Load will be variable. Who will be fixed? Source will be fixed. Source resistance will be fixed. But here, you got an opportunity to vary source resistance. If you got an opportunity to vary source resistance, outratedly change it to how much? 0. Why? 0 parallel to 12 gives rise to what? 0 source resistance. 0 source resistance is the property of an ideal voltage source, which does only ideal things, and one of the ideal thing is maximum power transfer. Another interesting part is, can you guess the efficiency? 100% efficiency, because whatever you apply, same thing will appear, which is not the case of practical circuits. When maximum power transfers, the efficiency will be equal to 50%. You please refer. But here, multiple benefits. Maximum power is getting transferred at the cost of 100% efficiency. So what is the answer? 0 ohms. Now, let me remodel the question again. Okay. Same question, but different circuit. What must be the value of capital R such that maximum power gets transferred from source to load? Okay. Question is same, but circuit is different. So let us say this is R, this is 12, and this is 6, and this is some 10 volts, which is VTH. Okay. Now, this is the situation now. Then you might wonder, sir, what's the difference between previous circuit and this circuit? Yes, there is a difference. You please recollect. Here also you might think, sir, just now you told R equals to 0. Chalo, R equal to 0, then maximum power is going to get transferred. So what is the right answer? You will say option D, but this is wrong. Why? Same circuit previously, you answered it as 0 ohms. Now you are saying 0 is wrong. Yes. In the previous case, can you please tell me what was the load resistance? 6 ohm was the load resistance. It is mentioned. This is load, this is source, this is RTH, this is RL. He mentioned it. But here, did he mention anything about who is load and who is source? No. If I ask you one more question, what do you think is the load resistance here? If you say 6, it's wrong. There is no hard and fast rule that always load resistance should be here, source resistance should be here, Thevenin's voltage should be here. For example, if I draw Thevenin's equivalent circuit like this, suppose let us say this is VTH and this is RTH and this is RL, then as per your theory, if I ask you what is the load resistance here, you should say it is short circuit. Is it so? No, it's a simple series circuit. Okay. So please do not judge who is load, who is source based upon its positions. they are not their permanent positions. Okay. Now, here what do you think? So, previously it was an ideal case, now this is the most practical common circuit. So, if he is asking what must be the value of R, he did not mention who is load, who is source, then obviously you have to assume this R as the load. Now, what must be the value of capital R such that maximum power gets transferred? So, what is the condition here? Your R should be equal to RTH. Now, calculate RTH. How to calculate RTH? Step number 1, remove the load, remove, deactivate energy sources, deactivate means short circuit. Now, look with respect to open circuited terminals. With respect to open circuited terminals, tell me how these two are connected in parallel. So, 12 parallel to 6, how much? 72 by 18, that becomes 4. So, what is the right answer? 4 ohms is the right answer. I hope you got the difference between the previous circuit and this circuit, right? When load is variable, the condition is RL should be equal to RTH. When source is variable, what is the condition? RTH must be equal to 0. Okay. Now, let me give you same question, circuit is different again. What must be the value of capital R such that maximum power gets transferred from source to load? Now, what do you think the answer is? Yes, finally a question that matches to your answer has arrived. What is RTH? 6. What must be this one? 6. Out of which how much is already here? 12. So, what should be this one? 12. So, here what is the load? 12 parallel to R is called as load, right? So, learning theorem properly will help you to answer quickly, or else you will stuck at that particular place only, you will never come out of that loop. Okay. So, this is one odd question that related to your theorem, especially maximum power transfer theorem.